recorded. I've, put it on to record, shut it down, and then I go back to my Dropbox in class, whatever the number is, 6B, 7B. So 5B and 6B have not been in my Dropbox. So when you go to, if you go to Moodle and try to get into your videos that way, you won't find 5B and 6B. So I'm hoping today, whatever has happened will be different. So if you need to get to the class videos, just go into YouTube directly and just type in Linda Kavanaugh, small letters. And like I mentioned to you before, there'll be a bunch of Linda Kavanaughs that come up. The first one's this like blonde woman who looks like an anchor or something, she's like a news, I don't know what she is. But if you scroll down, I don't know, maybe 11 spots, if you go down 11 rows, I don't have a picture in, so it's just that profile on you file. It will say Linda Kavanaugh, and you'll see like 7 videos or 8 videos. Just click there and use the videos for class 5 and 6 and 7, I guess, because 7s didn't happen either, for my class A. So in other words, my 840s class videos are in there, and they're the same material. Different questions, sometimes I vary my approach for our class based on the first class, but you can always get the videos for, like, it will say class 6A. So if there's no class 6B, just use 6A videos, okay? Is everybody clear about that? Because I know some of you are using those videos. I can see the number of views. It's exciting. Okay, so please put your take-home quiz, that blue sheet, and your projects in your folders. Today we're going to start section 6-7 in the textbook, but that's all we're doing. We're starting it. We're not going to totally complete it because it's like 5 or 6 different types of equations, and they put them all together in one section, and I think we'll do 3/5 of them today, and that's enough for our brains to handle. Your very last quiz is going to be during class 10, which is next Wednesday, and that's the class before our first test. And no, your last quiz for the first part of the course is what I meant to say. Sorry. So since you won't have time for me to grade that and give it back to you, just like I've done with quiz 1 solutions, I don't know if you've noticed, but on our Moodle site and the test prep block, you will see something called a folder called quiz solutions. And in that folder, you will see quiz 1 solutions, and this weekend I'll put quiz 2 solutions in, and I will have, so when you leave class next week, I'll have quiz 3 solutions, so you'll be able to look over the problems from quiz 3 and see how you did before, Friday. All right, so Monday's class 9, which is the last class in this packet, will be where we draw the line for the material, the content and material for our first test. Okay. So the first test is 1 week from today. 1 week from today, right? Okay. And it's on your schedule. Okay. Any other questions about where you can find things? And I just wanted to mention that if you have equations where you have more than one solution, so let's say your solutions for your equation you're solving is -4, 0, and 4. Okay, if you want to enter this in my math lab, remember they're always looking for a solution set, and they'll give you those little curly braces. You have to put the solutions in ascending order. Ascending means what? Smallest first, smallest to largest. Okay, that's what it means to ascend. So the first solution you would put in those curly braces is -4, then 0, and then 4. Okay, so you may want to make a note of that so it doesn't drive you crazy.
Like I was trying to fill on the homework, I kept getting them wrong because I was like, I couldn't. Anytime I tried to put 2 different terms together,
Are you talking terms or factors?
Or factors.
Yeah.
Factors on top of the division bar, it would separate.
Hmm. You could do this. So you have parentheses in here, chain, and then a bracket here. Try that. Try it right after class, and if you can't get it, I'll help you out. Okay? Anything else? Okay, so let's take a look at today's material. And Lenny, you want to start us off? Okay, so we call this a fourth degree polynomial equation. Why do we call it a fourth degree? Highest exponent, right. The highest exponent we see is 4. So this is why we call it a fourth degree polynomial. Okay, so fourth degree polynomial, the highest power you see is 4. And just a little reminder, every time you see a polynomial equation, circle that degree, and that will always tell you the maximum number of solutions. The maximum number of possible solutions. So our solution set for this particular equation could have 4 values. It could have no values. It could have 3 values. Okay. It could have 2 values. All right. And it, you can go all the way down. Okay. We don't know yet before we solve, but this just sort of gives you a sense of how many possible solutions you can have. Now we call this polynomial because all of our exponents are whole numbers. They're not natural numbers because you could have 0, okay, and that would make it a constant. So in other words, if I had an equation like x to the 5th plus 4x to the 4th equals 5, if I had to put a little something like that beside it, I wouldn't change it because x to the 0 power is 1. So a constant term has degree 0. So all polynomial equations are sort of really nice to work with because all of your exponents are whole numbers. And that means you'll never have any denominators. You'll never have x to a negative power, which now creates those yucky rational equations that take you forever to solve. So these are kind of nice, quick, and easy to do once you recognize your patterns for solving them. Okay, so we're going to use some of the strategies we use for quadratic equations to help us with some of these higher degree polynomial equations. And what we always do with a quadratic is we set our equation equal to 0. So what are we going to subtract from both sides here to set our equation equal to 0? 6x squared. We could subtract x to the 4th and x to the 3rd, but in one simple step, we can simply subtract 6x squared from both sides. And since there are no other squared terms on the left-hand side of our equation, we have no like terms, so we have 3 terms on the left-hand side. These are our 3 terms. Okay? So again, I'm up here using all this language, 3 terms. Remember, if you have an adding and subtracting problem, the individual pieces of an adding and subtracting problem are called terms. So these are our 3 terms. Okay? Terms are different than factors. All right, so now we talked about this the other day because Mary asked us a question on Wednesday, which was kind of nice because it is one of the typical things students do right now that you don't want to do. If you divided both sides of this equation, if you divided this by x squared and then the right-hand side by x squared, you certainly will make this side a lot easier to deal with. but you're going to reduce it from a fourth degree equation down to a second degree or a quadratic. And by doing that, you're going to lose one of your solutions. Because one of your solutions here is 0, x is 0. And so once you divide both sides by x squared or x to any power, you lose a potential solution. So that's why we never want to divide both sides of an equation by x to the first, x to the second, x to the third, because we'll lose one of our potential solutions. Okay? And also when x equals 0, you're dividing both sides by 0, which is not allowed. All right? So once we have our equation set equal to 0, then we can try to pull out of our little toolkit that we have sitting right beside us with all the different ways we've learned how to solve equations, this idea of if I can make this left-hand side into a multiplication problem equal to 0, then I know how to solve it. Okay? So in order to make the left-hand side into a multiplication problem, we need to do what we call factoring. So what factoring technique am I going to use to factor this type of equation? What factoring technique? Yes. Remember I already told you to write on your palm, GCF? Your best friend for solving polynomial equations. I'm serious, you can bring it into a quiz tattooed on both hands if you want. Greatest common factor, right. It is the first form of factoring that we all forget about, is looking for the greatest common factor. It's one of the, I think, most important, because sometimes you can't even get going on factoring an expression without taking out the greatest common factor. So what is the greatest common factor to x to the fourth plus x to the third minus 6x squared? What is the greatest common factor to every one of those? X squared. Okay? And the reason why it's not x is because you see that if you took out an x, then you would have x to the third plus x squared minus 6x. You'd still have another x in there. So it's kind of a little, I think, a little interesting play on terminology. The greatest common factor is the expression with the smallest exponent out of the three, isn't it? You have x to the fourth, x to the third, and x to the second. But the greatest common factor is the smallest power, x to the second. So you pull that out, and then you rewrite this where we've taken x squared out of each term. And now, lo and behold, you have a factor. Your second factor here is a baby quadratic. Well, it's not a quadratic, it's a trinomial. It's x squared plus x minus 6, and you've learned how to factor these. And so we factor this into two factors. So we say, what are the factors of 6 that differ by whatever this number is? 1. What are the factors of 6 that differ by 1? 3 and 2, I heard someone say it. Yeah, x and x, 3 and 2. And the 3 is going to carry the addition sign because it's a positive one. And lo and behold, I've now created an equation where on the left-hand side I have a huge multiplication problem. Well, not that huge. It has 3 factors that are equal to 0. And now I know, because in math, anytime I have a multiplication problem that equals 0, when any one of the factors equals 0, the whole thing's going to be 0. So now you take your time and you set each factor equal to 0. Each factor equal to 0. And notice your factors are now either a baby quadratic like this one, x squared equals 0. That's really a baby quadratic. Or it's a little baby linear equation, which you could solve when you were in introductory algebra, probably before you even took algebra. Okay, you could solve that. So we go in and we solve each one. X squared equals 0. X can only be 0. It's the only time when you take the square root of x squared, you don't have to worry about absolute value, because 0 square is 0. There's no opposite of 0, like there are all the other numbers have opposites. X equals -3 and x equals +2. Okay, so those are your 3 solutions. If you were to put these in my math lab, there's an order that's important. on your quiz or test, I don't care what order you put them in. You can list them any way you want. But for your homework, you'd have to put -3, 0, and +2. Okay? All right? Now, always check your answers in your original equation. Original. Because if you changed your equation in any way and made a mistake, right, then your answers are going to, and you put them into the equation that you changed, your answers will say, hey, this is true, when they're really false. So you always go back to your original equation. In this case, it was x to the 4th plus x to the 3rd equals 6x squared. And then you can see if I put 0 in, 0 equals 0. So let's try out our -3. -3 to the 4th plus -3 to the 3rd is supposed to equal 6 times -3 squared. Okay, so -3 to the 4th is 81. -3 to the 3rd is -27. And that's supposed to equal 6 times -9. 81 minus 27 is 50. Thank you. +54 equals +54. You're a happy camper. It works. Okay. And then you would also do the same thing for x equals 2. Right? So always check your answers in the original equation. Any questions on a polynomial? How to solve a polynomial? Okay, then I want you to turn to your group exercises, which I believe may be page 7. And at your seats and with your groups, and if you need me, just put the flag up. I'd like you to work on number 1. Okay, work on our equation list is going to grow very quickly. So if you put together some type of study guide like this for yourself, and this is like the first side of one of your pages you're allowed to bring into your test next week, you're going to have a huge summary of how to solve equations. So that when you get to the solving equations section on your test, you just look over to your study guide and say, oh, that looks like this kind. Oh yeah, we call that polynomial equation. Here's the type of idea I'm going to use. All right. So this is one way for those of you who have always had difficulty organizing stuff to study or how to organize a study sheet. This is one suggestion that I have. Okay. All right. No, we haven't finished yet. I was just giving you some examples, but you're just as capable to just finger through each chapter in your book, each section, and see what type of equation. No, we haven't finished yet, Shane. We're going to have a few more. So let's take a look at radical equations. Now, radical equations are pretty, like they hit you right in the face. You don't have to like look too hard to try to identify them because you'll see a radical sign. Yay! So at least you can identify them fairly quickly. And the idea that we use for solving a radical equation is to use the same idea we use when we solve linear equations, which is to isolate what we're trying to solve for. So you look at your variable equation here, x plus the square root of x equals 12, and you wait a minute, what am I trying to solve for? I see x, right? I see an x, and then I see a square root of x. So do I try to get my x all by itself or my square root of x all by itself? So when you have a radical equation, you always want to isolate the radical term. So this is what we want to isolate right here. We want to get this all by itself on one side of the equation. Okay? So we want to isolate the radical term and subtract x from both sides of the equation. Okay? So the first thing we're going to do is we're going to subtract x from both sides of our equation and take a look at our new equivalent equation, which now looks like the square root of x equals 12 minus x. Okay. Now, the next thing I would do is anytime I see that I have one side of my equation with more than one term on it, I'm going to put my arms around it, my parentheses, so that if I have to raise it to a power, I'll do it appropriately. So I'm going to put my arms around this. I'm going to put it in a different color. Keep me nice and safe. Okay. So now I have my radical equation with my radical on the left side and my two terms on the right side, and I'm all set to undo the square root. So what's the inverse operation of taking a square root? How do I undo a square root? I square both sides, right? Square. So now I go in, and where I see the square root of x, I say, okay, I'm going to undo that by squaring that side. And whatever I do to the left side, I know in algebra I must do to the right side. So I'm going to square both sides. So we're going to simplify both sides of our equation, and we know that when we square something, it undoes a square root. And I'm just left with x to the first power, which is what I always want to have. And now what is the right side simplified? 12 minus x quantity squared. What's my answer there when I simplify that? I'm waiting to write. Yep. Be careful not to fall into temptation. What the heck is Kavanaugh talking about when I say, yeah, you don't square the 12 and you don't square the x. You can only do that when you have multiplication in here. If you had 12 times x, it would be 144x squared. If you had 12 divided by x, it would be 144 divided by x squared. Adding and subtracting, whole separate part of algebra. Okay, what you do with adding and subtracting is different than what you do with multiplying and dividing. So you would square this out the long way if you had to and use FOIL. Some of you still don't recognize, and that's okay. If you don't, you can just use FOIL here to get the same answer. Well, how to square a binomial quickly. It doesn't matter that you're quick. It's all right with me. And now you have to solve, what kind of equation do you have right here looking at you? What kind of equation is that? Quadratic, right. So from there, it should be a piece of cake, right? Because you know how to solve quadratic equations. You're masters of this by now. You subtract x from both sides because you want to set your equation equal to 0. And then you look at your expression here on the right side and you say, I really hope I can factor that easily, because I tend to screw up sometimes when I use my quadratic formula, right? I mean, some of you are really good at it and some of you still make little mistakes. So again, the question is, can you factor that easily? No, because I've subtracted x from both sides, Shane. Negative 24x and another x gives me negative 25. Okay. So let's see if I can factor 144 so it adds up to 25. So over here on the side of my paper, I know here are two factors of 144. Well, those do not add up to 25. It's way too big. 2 goes in 72 times. 2 and 72 is way too big. That doesn't give me 25. If I add the digits of 144, 1 plus 4 plus 4, what number do I get if I add the digits? 9. That tells me it's divisible by 3, since 9 is divisible by 3. So 3 goes into this 48 times. And now you start saying, oh, I'm not sure about 4. I know 5 doesn't go into it because it doesn't end in 0 and 5. So you start looking at these other ones here and thinking about factors of 48 and 72. 48 is 6 times 8, right? So that means I know 6 is going to go into here. So 6 goes into here, 6 goes into 14 once. And what do I have left over? 84. 6 goes in, is that right? 6 goes in 19 times. Okay. So now I start seeing these two things do not equal 25 when I add them. These two things do not equal 25 when I add them. These two things do not equal 25. Oops. 6 and 19. What? 6 times 19. 100. Ooh, 114. Right. 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 Okay, I was going to get there. All right. So again, it's just 6 into 144. When I said once and I said nope, and then he said 19, so I wrote what he said because I knew I had to go twice. 12, 4 times. Okay, so 6 times 24. So does that work? Nope. That doesn't equal 25. So you start to lose hope. But you know you got an 8 coming up because 8 goes into 48. So let's try 8. 8 goes into 144 once. 18 times. Are you getting closer to 25? 8 and 18 is 26. You're really getting close. So what's the next thing to try? What numbers divide 72? 8 we've already tried. What would be the next one you'd want to try? 9. So 9 goes into here 20. How many times? Once. 16 times. 9 plus 16. So I can factor this. X minus 6. X 15, x minus 16, x minus 9. And there are my two solutions. Or you could use your quadratic equation. Excuse me, your quadratic formula. And guess what? When you use the quadratic formula, you're going to get exactly the same answer. The numbers are kind of big to work with, but they're not too bad. X equals negative b plus or minus the square root. B is negative. It's got to be in parentheses. If you put minus 25 square on your test without the parentheses, I will take off for it. Because negative 25 in parentheses squared is not the same thing as minus dash 25 squared. It must be in parentheses. Minus 4 times 1 times 144. All over 2 times 1. So that's x equals 25 plus or minus the square root of 625 minus, what is it? 4 times 144. Come on, you got calculators out there. 576 all over 2 equals 25 plus or minus the square root of 49 all over 2. So that's 25 plus or minus 7 all over 2. So our two solutions are x equals 25 plus 7 over 2, which is 16, and x equals 25 minus 7 all over 2, which is your 9. So what a lot of people in my first class didn't know, and we'll see, you can check your own self. I'm not going to ask you if you knew this or not, but anytime you use your quadratic formula and you come up with rational numbers for your answer, 16 and 9 are rational, that tells you your original equation was factorable. The only time you can't factor it is when you end up with irrational or complex numbers there. So you see this stuff, this big box here, mandatory, mandatory. And I wish I could have sound effects like when we get here to have like flashing lights and, okay. You have to check whenever you raise both sides of your equation to a power. You have the potential to introduce solutions that do not work in your original equation. This is one of the times that this happens. And you can check this on your calculator later on. If you put this into your graphing calculator, your original equation, and then you put in this new quadratic, you get two different pictures. The quadratic's going to cross the x-axis in two places at 16 and 9. That's going to be your x-intercept. This equation's only going to cross it at one spot. So you have an extra solution. We call them extraneous. And the only way to find it is to go back to your original equation, which was x plus the square root of x equals, what was it, 12? 12. And plug in each one of these to find out which one is not in your solution set. So you do 16 plus the square root of 16. Does that equal 12? 16 plus 4? Does that equal 12? No. So 16 is extraneous, nada, no good. It's not there. Well, let's try the 9. Hopefully that will work. So we got x plus the square root of x equals 12. We throw in our 9. 9 plus 3. Oh, thank goodness. I didn't go through all that work for nothing. So our solution set here has one answer in it. And that one value is 9. Okay? So that's the kind of thing when you're prepping for the test next week, beside a radical equation, you'll want to say, It's 25 plus 7 divided by 2. Okay. So what was I saying? Oh, when you're prepping for your exam next week, make sure when you put the part in for radical equations, you put big whatever you want to put around it, or use a day glow highlighter and say mandatory check your answers for maybe a potential extraneous solution. Okay? So now I'd like you to go to page 17, and I'd like you to work on the second equation here, form. So let's go back into our lecture notes to where we see equations with rational exponents. And Tara, you want to read this for us? Okay. So solve the equation 3x to the 3/4 minus 6 equals 0. I could be wrong because some of you seem pretty comfortable with solving radical equations. So, you just so you know, you will have two choices when you see this. I want to show you another approach when you have a radical exponent. Okay. So let's take a look at what this other approach is. So first of all, don't let that itty bitty teeny weeny, I'm going back again to the 50s now. There was a song, itty bitty teeny weeny, na na na, the bikini. Does anybody know that? What did you say, Ian? What, itty bitty teeny weeny? Really? Why is it in your head? Who put it in your head? Just now? Yeah, but you knew what it was. I didn't say yellow dotted. I didn't say yellow whatever polka bikini. You what? Oh, yo play? Okay. All right. So anyway, don't let the itty bitty exponent here frighten you. You can think of this just as if it was 3x minus 6 is 0. And if we started with an equation like 3x minus 6 equals 0, what would be your first step? If you had an equation like 3x minus 6 equals 0 and I asked you to solve it, what would be your first step? Add 6 to both sides. Same thing. Add 6 to both sides. Because we're still trying to isolate the term on the left side that now, instead of having a radical in it, has the rational exponent. Okay, so you add 6 to both sides. We end up with 3 times x to the 3/4 power equals 6. Okay. And so now if we carry the, analogous situation here as if this were a linear equation, and we had, over on the right, we had 3x equals 2. Oops, 3x equals 6. Plus 6. We had 3x equals 6. What would be the next step so that we get x all by itself? We divide both sides by 3, right? That would be our next step. We want to get the coefficient of our term to have a 1 in front. Same thing. So our next step, our second step, is to divide both sides by 3. Okay, so I'm going to divide both sides by 3, and I get x to the 3/4 equals 2. Okay, so here's where the new idea comes in. Back if this were a linear equation, we'd be done and we could put a little circle around that and say there's our solution, x is 2, right? But we're not done because it doesn't say x to the first power, it says x to the 3/4 power. Okay? So we need, in order to solve this, we want to make this equation say x to the first power. Okay? So when we had a radical like square root on the left side or right side, we undid the square root by raising both sides to 2. We essentially made an exponent of 1. Because what we didn't show was this step right here. And this will help you see the strategy that we're about to use. When you have the square root of x equals something like this, 6 minus x, when we say square both sides like this, what we do is we just kind of say they undo each other without ever showing the mathematics of why it works. And here's the mathematics behind it. Beside the fact that they're inverse operations, if we take the square root of x and we write it as x to the 1/2 power, which is what it means, what we're doing when we square both sides is now we can say I can use my exponent properties. When I have a power to a power, I multiply. But these two numbers right here, 1/2 and 2, have a special relationship to each other. Does anybody know what these are called, 1/2 and 2? What? Reciprocals, right. When you multiply reciprocals, you always get 1. So what we just do with these little crossing each other out is we've created an exponent of 1. So whatever this exponent is here, whatever the radical is, you raise both sides to the reciprocal. Well, when you just have 1, when you have x to the first power underneath the radical, you're only concerned with undoing the root. Okay? I'm having a really hard time with table number 5 today. So afterwards, I would like table number 5 to stay so I can talk to you about classroom behavior. Thank you. So x to the first equals 6 minus x squared. Okay? So if we now think back to the equation we now have it in this form. We have a rational exponent. So what we want to do here is we want to figure out what do I raise both sides to so that when I'm done multiplying 3/4 by whatever I raise both sides to, I get a 1, x to the first. That's what I want. So does anybody know what I could raise both sides to so I get x to the 4th power? 4/3, and that's because it's the reciprocal of 3/4. Okay? It's because my exponent rule says 3/4 times 4/3, which is 2 to the 4/3. And 3/4 times 4/3 just gives me 1, and there I'm left with 2 to the 4/3. And there's no way I can simplify that any further because the cube root of 2, I can't simplify that. So you can leave it just like this. If you want, you could put it in radical form, cube root of 2 to the 4th. It doesn't matter. Okay? So the key here, the really new strategy is right there where you see whatever your exponent is and you say, oh yeah, if I raise it to its reciprocal, I'll create a 1. Now you want to check your solution. So let's go back because this will give you a little work on your exponent properties. 2 to the 4/3 gets substituted in back here for x. So let's rewrite that original equation. 3x to the 4/3 minus 6 is 0. And now I want to substitute in my solution, which is 2 to the 4/3. So let's input that in. So where I see x, I'm going to put 2 to the 4/3. I'm going to raise it to the 4/3. Is that my original equation? Or is it 3/4? Thank you. I figured it was wrong because I knew it wasn't going to work out. Okay. 3/4. So this is 3/4. Let me make that look a little bit better. I know what I'm, yeah, I know what I'm, so this is 4/3, and this is 3/4. Minus 6 equals 0. Notice I went back to the original equation. So I got to simplify this power. 2 to the 4/3 raised to the 3/4. I multiply my exponents and I just get 1. 2 to the 1. Well, that's nice. So I get 6 minus 6. 0 equals 0. You're a happy camper. Okay? So that's how you would check that. So what I'd like you to do now is I'd like you to work on, well, actually, I'm going to go back. I'll leave you 5 minutes to work on that last problem, but I want to go back and show you how you can use 2 different methods in your exponent, in your graphing calculator to find solutions to polynomials. So we started off with this polynomial equation, and we've actually already talked about one method back in class 5 for using our graphing calculator. So let's review that real quick. So here we have x to the 4th plus x cubed equals 6x squared. I'm telling you that the solution to this, the solution set to this problem is -2, -1, or 2. Okay, so let's take a look at the method that we actually spent some time in class 5 looking at. And that's where you take each side of your equation, you put it into your graphing calculator, right, as y1 or y2. So if you take out your calculator, let's do that and see what we get, how we get this particular solution set. So we got y1 is going to equal x to the third plus x squared. Y2 is going to equal 4x plus 4. Okay? So what is our goal here? Our goal is what values of x make the left side equal to the right side. So if each of these represents two different equations, we want to find where those two graphs intersect. That's the key, the intersection points. So you graph these and you try to find where they intersect. Okay? Now sometimes you have to zoom in a little bit to see the actual values. Okay, but to find, let's suppose they weren't nice points, so you could just look at them and see. We know they're -2, -1, and 0, but what if they were -2.1785? To find the intersection point, you hit second calc, and you go down to number 5 that says intersect. And there's your first curve. You can bop over and put it on your second curve. As long as you're close to the intersection point, all you have to do is hit enter, enter, enter. And there is your first intersection. And what does that tell you? When x equals -2, your two y values in your table. So what it would look like in your table is you'd have x, and at -2 you'd have y1 would be -4 and y2 would be -4. So if you put -2 up here into your equation, you get -4 on the left-hand side and -4 on the right-hand side. Okay? Yeah. Yeah, because the next one is -1. You just have to move your cursor further back to the left. Yeah. Oh, I know. I forgot to. I know. I made a little error here. I forgot I had a typo on here, and I forgot to have you guys change it. I have my. So first of all, do you see that this equation and this equation isn't the same? So this should be. This is what I'd put into my calculator. This equation. This doesn't work? Really? Do you have your stat plot on by any chance? Because that will show that that's looking for lists versus equations. So up here, if you see any one of these plots on Sam, that's going to give you an error, a dimension error. Okay, so I'm sorry, I forgot to tell you to change that to 4x plus 4. All right? And then if you keep going with this intersect, you'll get all three of these methods. That's one idea, folks, right? Where you create two separate graphs. You're trying to find what value of x makes the y value the same. That's intersection. The new idea is this, the page before that, number 2. It's sort of how we're solving these equations. When we solve these equations, we throw everything over to one side of the equation, right? And we set the equation equal to 0. So let's see what's different with our graphing calculators if we use that idea. So when we set this equation equal to 0, we still have one equation. We have 1 instead of 2. So let's enter the new equation into y1. That's going to be x to the third plus x squared minus 4x minus 4. Okay? So I'm going to set that equation equal to 0. To enter it into my equation, I have to change the 0 to y1 because my graph is going to give me all values of x and y. The one that I'm going to be interested in finding out is what value of x makes my y value equal. What's that called? What point is that on any graph? The value of x that makes y 0. X-intercepts, and that's the key. So this idea, you find your x-intercepts. The other idea, you found where your two graphs intersected. Now, as we go through the course, sometimes this method will be the quickest and easiest to use, and sometimes your other method will be the easier one to use. And you'll have practice to know which one is better. Okay, so I'm going to now, instead of having two equations entered, I'm going to just go back and put in x to the third plus x squared minus 4x, and make sure you use your subtraction button or you'll mess up. Minus 4, all right? And I graph that. Oh, second calc, let me see, just graph it first so you can see what it looks like. So notice, how many different spots does it go through the x-axis? 1, 2, 3. That tells you your three solutions. To find those three solutions, let me get a little picture of this so you have it for your notes. You want to take on your own papers, you'll just want to draw a quick image of what this looks like. I have the advantage of being able to cut and paste, but you can just draw that real quick, right? It has one hill and one valley, and it goes through -2, -1, and +2. And so the values of the x-intercept represent the solutions to the equation that we're trying to solve. Why? Because at each x-intercept, the y value is 0. And that represents the solution to my equation. So you might say, well, what if I can't see where it hits the x-axis, or it's not a nice number? What command do I use? You go second calc, and this is a new term you don't know unless you've had algebra before, like pre-calc or whatever, or college level algebra in high school. You don't see x-intercept anywhere along there, do you? It doesn't say x-intercept. So where are you supposed to go? Does anybody know? Value means you can put in any x value and it will give you the y value. That's a good guess. 0. Because in a little bit of time, these spots where your graph crosses the x-axis is what we're going to call the zeros of your equation, which we're going to call a function in a little bit. So 0 means what values of x make my y value 0. So you come down to 0 here like this, and let me show you a real quick shortcut. You don't have to move the cursor all the way over so that you're on the left side or the right side of wherever your particular x-intercept is. You can just say to yourself, hey, I know I'm around -2 right here. Let me find a number to the left of that. Any number to the left of -2, and all you have to do is throw it in, like -3. Boom, like that. There's your left bound. Then you go to a number to the right of -2, but you can't go too far because you're going to bump into this x-intercept. So you've got to pick a number between -1 and -2. -1.5 is a popular number. And then you'll get your guess, and you just hit enter, and boom, there's your first 0. It's the value of x that makes y 0. There's your first solution. So this is another way you can use your graphing calculator to solve polynomial equations. Now, why would you need this method? Because you can get, real quickly, you can get polynomial equations that you cannot factor. And you cannot solve through factoring, so you have to use your calculator and get estimates of your solution. So you need to do this 3 times, 2 more times, to get your other solution. Okay? Have a great weekend. I'll see you all later, and Dan, you can leave.